Okay, we're now working on number 4. We are given g of x equals 3 times the absolute value of x plus 2, close absolute value, minus 4. If we compare this to the standard equation y equals a absolute value of x minus h plus k, we can identify the a, h, and k of our given equation. The a is 3, the h is negative 2. Because of the negative here, we actually see the opposite of what we have. And our k value is negative 4. We'll need this information to sketch the graph. I'm just going to put a very basic graph here. It's just a sketch. To start, we know that our vertex is hk, or negative 2, negative 4. We put the first point for our vertex at negative 2, negative 4, and we know that our slope given by the a value is 3. So we go up 3, 1, 2, 3, and over to the right 1. Because this is a symmetric function, we know that we have another point on the other side of what would be the axis of symmetry. I'll draw that in a moment. 1, 2, 3, and over 1. Do the same thing on the other side. Sketching the graph, we get a V-shaped function that looks like that. I will put in the axis of symmetry. We know that is the line that splits the graph in half. And we can also label it x equals negative 2. Now, what is the domain of g of x? We think of domain, those are x values. How far left to how far right? Because our graph goes forever in both directions, left and right, we would say our domain is negative infinity to positive infinity. What is the range of g of x? We think of that as how far down to how far up. Our graph goes all the way down to negative 4, closed at negative 4 because it includes that value, and goes up forever and ever, so we get positive infinity. We've already stated that the vertex is negative 2, negative 4, and that the axis of symmetry is x equals negative 2, using this same x value as in our vertex, because of course that line goes through the vertex. What is the minimum value of g of x? Our minimum value is the same as the lowest value of the range. It is negative 4. If f of x was just the absolute value of x, describe the transformations of f of x that were used to create g of x. Remember, the absolute value of x would be our parent function as the parent function. If we compare it to our original standard form up here, we see that our a value is 1 for the parent function, and the hk, or vertex, is 0, 0. So what transformations have taken place to create g of x? Well, we have stretched the function vertically by a factor of 3. And we have shifted the function from the original vertex of 0, 0 to the left 2, given by h of negative 2, and down 4, given by a k of negative 4. So again, stretched vertically by a factor of 3, shifted left 2, and down 4.